Welcome to the thermal system design tutorials. Through these tutorials, you're gonna learn the basics on how to use ANSYS, which is a simulation software that is gonna help you out on this class and in many other engineering applications. You'll find out that in the workforce, it's one of the most highly used softwares in order to simulate. So let's go to it. So first of all, after you download ANSYS, in my case, I downloaded ANSYS student version 2021. You're gonna try to use Workbench. So sometimes, whenever you download ANSYS, it's not gonna give you the option to go to Workbench right away. So sometimes you'll have to go and navigate through your different apps and through your download files and find Workbench. In my case, I already have it on here on my desktop, so I'm gonna open it. And after you open it, you're gonna get a similar interface to what I'm looking at right now. So let's navigate through this interface for a minute. So in your left hand side, you're gonna see the analysis systems. The analysis systems is the different simulations that you're gonna perform depending on the engineering problem that you're presented. For example, in this class, you're gonna use a lot of fluid flow, or also known as fluent, in which you'll simulate solid bodies and their interaction to different fluids. So that's one of the analysis that you can perform in ANSYS. For example, if you're just given a simple load and you just want to see the stress or the strain, or for example on a beam or anything alike, you'll use static structural. Or for example, if you have also loadings that involve some change in time and you want to see the dynamic response on them, you use transient structural. Those are some of the most basic things that you're gonna use in ANSYS. So these are the analysis systems. Most of the time, you're not gonna use any of the other available options on the toolbox, such as component systems. Most likely, if you go a little more into research, for example, you're gonna use some mechanical APDL or and or other components of the component systems. But most of the time, especially for this class, you're gonna use the analysis systems, and in our case, we're gonna use the fluent. So if we're gonna perform a fluid flow simulation, we can either just click on it, or we can drag it to the project schematic screen, and it's gonna pop up like this. Some of the times, for example, let's say that we're performing the very beginning a transient structural or a static structural problem. So we design our geometry, we design everything, we have all of our results, and then we want to switch, or we want to perform another simulation with fluid flow. Then we'll grab this one. And one of the cool things that the interface of ANSYS has is that, for example, we can connect these two geometries just by dragging them out, and they're gonna start sharing the geometry. So it's one of the cool features that you can do on ANSYS. You can have multiple simulations of a pretty similar problem in these different analysis systems. So, but let's focus right now on fluid flow. So here in fluid flow, uh, we are gonna consider some of the basic things of performing any simulation. So in any simulation that you're gonna do in this class and in future engineering work, you have to consider several parts. First is all the pre-processing, which will be setting up your geometry and setting up your boundary conditions, um, where your loads are, any the material that you're using, everything that involves the setup. And from there on, you're gonna start producing some results. The last step would be to post process those results. As engineers, we are to understand the results that, in this case, our simulations are giving us. And well, in the case that the results do not make sense, then we'll have to go back to the pre-processing, check our geometry, our boundary conditions, and our meshing in this case, in order to get the actual results that we're gonna need for either an experiment or any engineering problem. So this is the fluid flow and the project schematic. Here on the bottom, we have the progress. So here is going to tell us whether if we are getting an error when performing our simulation, or if our simulation is good to go. This is very important. Sometimes whenever you encounter an error, if you look the error on Google or in internet, you'll be able to find the solutions, or you'll be able to know why you're getting the error that you're getting. Here on the right side, we have the properties of the different things that we have. For example, we go to geometry, and it's going to give us the basic. For example, here on line 7, we can see the basic geometry options. So for example, let's say that we're performing a 3D simulation. If we're performing a 3D simulation, we will want this box to be highlighted, because we will have some extrusions and everything. So we want our simulation to actually detect that we're having some 3D bodies on it, right? Sometimes you can just not click on that one and just have surface bodies if we're ever performing a 2D simulation. So some things to consider. Every time that you start any type of simulation or problem on ANSYS, we're gonna select the analysis type. This is where we're gonna tell ANSYS if we're making a 3D or a 2D problem. It's very important, because if you have a 3D geometry and you select a 2D analysis, it's not gonna give you the results that you want. So some things that to consider in every time that you go into any simulation. Now we're gonna cover a little bit about the geometry. So if you right click here on geometry, it's going to give you two options. It's going to give you a space claim geometry or design modeler geometry. So right now I'm going to cover just design modeler. You can go ahead and you can play with space claim as well. Uh, Design modeler is going to be one of your best options, or you're going to feel more familiar with the interface of design modeler as it is opening right now. So Design Modeler, it's pretty similar to other CAD softwares, just like NX or SolidWorks, where you're gonna have your sketching options, your modeling option, your extrusion, the revolve, and almost every option from any CAD software. So it's one of the easiest. It's from the two. It's one of the easiest to use. So we're gonna go with this one. So anytime that you start any project, in this case, we're gonna go ahead and go to units. So in previous versions of ANSYS, actually, whenever you open ANSYS, it gives you the option right away to select the units that you're gonna work on. In this case, on ANSYS 2021, you don't have that option. So you're gonna go to units, and you're gonna select what you're working with. Let's say, for example, we're working with millimeters. Uh, every case is gonna be different. And lastly, we're gonna go over some of the sketching tools that we have. So we have, as any other CAD software, we have the option to draw a line, tangent line, the circles. We can navigate through them to construct a point. We also have the option to modify, uh, to do some fillets, chamfer, the corner to trim, drag, cut. We also have are ways to setting up our dimensions, the constraints that we want. Either we want a fixed constraint, horizontal constraint, if we want two lines to be parallel, or if we want if we have multiple circles and we want similar radius, etc. And lastly, we have our settings. We're not gonna mess with this a whole lot, but yeah, we have our drawing, and here on the right right corner we have the axis in which we're working on, right? So very important to know and to be consistent on the axis that you want to work, depending on the problem that you have. You can typically go like this, and you can start drawing a line. It should give you like an option that it says, like for example, here if I drag my cursor to the center, it gives me like I'm having a point. So for example, if I want to just make a simple rectangle, it's going to give me the option to do a point right here too. Obviously this is not going to be very precise, but you get the idea. You have the normal option to undo. If you want to actually make a good rectangle, you can choose the option and draw it from the origin. And through the other tutorials, I'm gonna go more into a specific example on how to use the geometry and how to start using and performing some simulations on Fluent.